Welcome. So in this video, we're going to be answering this question. It says the function f with the rule f of x is equal to x squared minus 4x plus 3 is shown on the graph below. Here it is. All right, what's the first thing we need to do here? The first thing we need to do is write down the coordinates of the y-intercept. So we have to write down the coordinates of the y-intercept. Remember, this is worth 1 mark, so we want to do this as efficiently as possible. So what we're going to do is we're going to come to our CAS, and we're just going to begin by defining our function. So I'm going to go f of x, and then I'm going to go control this button, x squared minus 4x plus 3, like that. Then once I've done that, the next thing I'm going to do, well, what's the easiest way to find my y-intercept? It's to let x equal 0. So I could go f of 0, whoops, is 3. And just like that, I found my answer. Now, let me tell you where most people would lose marks here. Most people would just write down 3. But see how it says coordinates? So that means your answer has to be 0, 3. If you don't put your answer as coordinates, you'll lose out on that entire mark. So be careful for that. And let's just put that piece of information on our graph here. So this right here is going to be 0, 3. Perfect. Having now done that, we can go on to our next question, which says, find, so the x values for which the function is less than 0. So we can do this without actually using our CAS. We could simply see that the only regions where it is less than 0, or in other words, below my x-axis, is here. So it's between 1 and 3. So let's now write down that as our answer. If we wanted to use the same notation as the question itself, we could do this. We could say x, and then we could go, it's between 1 is less than x is less than 3, and then close it up again. So as you can see, for this, we didn't even have to actually use our CAS to answer it. Also, you should realize that you can write this with different notation. You could write x is an element of, and then go 1 to 3. Just make sure you're using the right brackets. They have to be round brackets because I don't have or equal to sign there as well. If you, for whatever reason, did want to use your CAS, you could. It would probably be a bit of a waste of time, but you could anyway. You would go menu, you'd go algebra, you could go solve, and then you could go f of x, and then go control. This is less than 0, and we're doing it for x. Close your brackets, and as you can see, you're getting 1 to 3, just what we said there. So it's just another way of doing it. Let's now come to C here. So let's zoom out. So we've gotten so far. So it says express the rule for f in turning point form. As you can see, this is worth 1 mark. So we don't actually want to complete the square by hand. It's only worth 1 mark. So we want to use our CAS. So as you can see, the CAS is very important. So what we're going to do is go menu, algebra, and you can see complete the square. So let's click that. Whoops, I didn't actually do it properly. Sorry, do here, menu, algebra, complete the square. And then you type in f of x. You have to go comma x. If you don't go comma x, it won't work. And there's our answer right there. So let's now write that in. So we can go f of x is equal to x minus 2 squared minus 1. Then it says write down the coordinates of the turning point. So we can immediately identify that as 2, negative 1. And let's come up to our graph and put that in as well. So we can say that this point right here is going to be 2, negative 1. So this is 2, this is negative 1. Perfect. Let's now keep moving on. It says write down the domain and range of the function f. So if we come up here, we can have a good look at what we're dealing with. So what would the domain of f be? Well, it's quite simply going to be all real numbers because it just exists for all possible values of x. My range of f is, think about it, is all for all your possible values of y. And here it's going to be from negative 1 to infinity. No y values exist below this. So I'm going to go from negative 1 to infinity like that. So let's now write both of those in the space provided. So we come down here, and I'm going to go, the domain is going to be all real numbers, and my range is going to be negative 1 to infinity, like that. Perfect. Next, explain whether or not the function f has an inverse. Explain whether or not the function f has an inverse. So if we were to come up here for a second and look at our graph, what do we have to remember about inverses? Well, in order for the inverse of a function to exist, it has to be 1 to 1. And the way that we determine whether or not something is 1-to-1 is if it passes the horizontal line test. And as you can see, this doesn't pass the horizontal line test, which means it isn't 1-to-1, which means it won't have an inverse function. So we need to write all that information down here. So let's come here, let's get our pen, and let's go no, since it is not a 1-to-1 function. It is not a 1-to-1 function since it fails, that's not how you spell fails the horizontal line test. Perfect. Nice and thorough explanation there. Next it says, for part F, show algebraically that the graph of y equals f of x intersects the line y equals 2x minus 6 at one point only. Okay, the most important line here is it says show algebraically. So we could easily do this on the CAS, and let's do it on the CAS just to start ourselves off, so we can kind of situate ourselves a bit. Let's go control, doc, let's go add graph, let's graph f of x, and then remember you hit tab and we can graph 2x minus 6. Whoopsie daisy. 2x minus 6, enter. And as you can clearly see, it only intersects it once. Menu, analyze graph, intersection, whoopsie daisy. From here to here, as you can see, 3, 0 is the only place it intersects. And this is all well and good. We can use this to make sure that we've done it correctly, but we have to show this algebraically. So how would you show this algebraically? Well, what you're going to do is you're going to take the graph, so the function. So take the function, which was x squared minus 4x plus 3, and you're going to set it equal to 2x minus 6, because remember, you set things equal to each other and then solve for x for when you're dealing with intersection. So let's now minus 2x to both sides. It's going to be minus 6x, and let's plus 6 to both sides, plus 9. This creates a perfect square, so it's going to be x minus 3 squared is equal to 0. And then remember, we're solving for x, so the next thing that I would do is I would square root both sides, which is going to leave me with x minus 3 is equal to 0, because the square root of 0 is just 0, and then x is equal to 3. Then what I would say is, just to provide a bit of an explanation, since there is only one solution, there is only one point of intersection. Is only one point of intersection. Perfect. There we go. That's all we'd need for that one. Since there is only one solution, there is only one point of intersection, because it wanted us to show algebraically that the graph of y equals f of x intersects the line y equals 2x at one point only. Okay, next. The graph of y equals f of x is to undergo a transformation. Write down the equation of the transformed graph if the graph of y equals f of x is translated 1 unit right and 2 units up. So 1 unit right and 2 units up. So what we're going to do here is we're going to utilize our turning point form. So this one right here, so let's just write that down. That's the one we're going to use instead of our other form, because it's easier to deal with. So we're going to deal with x minus 2 squared minus 1. Now that we've done that, if I'm going 1 unit right, we have to think. Remember, it's always counterintuitive to what you think. If I'm going 1 unit right, that means I'm minus 1 here. And then if I'm going 2 units up, it means I'm plussing 2 there. So that means what my final answer is going to be, and I might even write it in red, it's going to be y is equal to x minus 3 squared plus 1, because minus 1 plus 2 is plus 1. That is going to be our answer. Perfect. Let's now go here. Now, reflected in the y-axis. So I again am going to start with what I started with. So y equals x minus 2 squared minus 1. That's what I'm starting with. And if I reflect it in the y-axis, remember what you're going to do is you're going to take your x value and you're going to make your x value negative x minus 2 squared minus 1. And that means what my final answer is going to be here is y is equal to negative x minus 2 squared minus 1. Just like that, we have our answer. Y equals negative x minus 2 squared minus 1. Perfect. Hopefully all of that made sense as I went through it, and it all seems doable now that you've seen it in the video. Alright, with that being said, hopefully you enjoyed this video and you were able to follow along. I'll see you in the next one.